This is a continuation of the previous video where we were looking at the comparison of the bracket notation we normally use for an array versus the pointer notation that we're just learning about. Then in the previous video we looked at the array odd, which I declared up here, but this was one that we declared in a normal way where you just have your type and the name of the array, the brackets, and then we initialized it. So that's the common old-fashioned normal way to declare an array. This time what I want to do is I want to make a dynamic array, and let's see how we can treat that one differently, if at all, from the standard array odd. Starting out, then we're just going to create a new dynamic array, and we're going to ask for input in order to create the array. So first of all, for a dynamic array, we need to have a pointer for that. So I'm going to call the pointer even. So even is a pointer to an integer. It's initialized to the null pointer, and that's what we're going to use as our array. We are going to prompt to ask for the size of the array. How many elements do you want? And then we can type in whatever number of elements we choose. Then we can do the dynamic allocation of the array here using the new. So one more time, I know this is repetitive, but the idea here is that whenever you use new, the operating system is going to allocate enough space for the array, and then it returns the address and it stores that into this variable here. So we know already that we have as the name of an array, that is the address of the first element of the array. So then, once we have allocated that, or to be correct, we have requested that the operating system allocate that, our program has done that, then the operating system will cooperate with us and it will allocate the space. So then we're good to go. Now once that has been allocated, then we can use the standard square bracket notation in the same way that we would normally. Since we're dynamically generating the array, then I can't initialize it beforehand, so we have to initialize it after the program gets going and after we allocate it here. So to initialize the array, I'm just going to put even numbers into the array, since after all the name of the array is even. So we have our little for loop, k goes 0 up to the number of elements, and we have the k++. Then we just fill it up. So this will put in the even numbers 2, 4, 6, 8, and so on. So k starts out with 0, so k is 0 to begin with, so the first element is 2. Then we have 4, 6, 8, all the way up to the number of elements that we requested. After we've done that, then let's print out some information about the array. So let's start out by just printing out some simple cout statements, and let's investigate how this array is going to look. So let's put some cout statements in here. And I'll do the same thing I did in the previous video, where we will print out the first element of the array even. We'll print out the address of that, because even is, after all, just the address of the first element of the array. And we will dereference that first element and print that out. And we'll also print out the address this time. So we'll see where the address of even is that the operating system gave us. So let's compile the program and look at these outputs. Now the program is running, so we're being prompted for how many elements do you want for the array. Okay, let's keep it simple. I'm just going to enter 10, and then the output that we get to begin with here is showing up here. So even sub 0, that's going to have element, the value is going to be 2. The address the operating system gave us is shown here. Then if we dereference that address, then we get the value 2. So we see that this is the same thing. That's the pointer notation. Here's the bracket notation. And if we get the address of a variable even, we see that this is the address here. So even is a pointer. The pointer has an address in memory that's shown there. And the contents of that pointer would be the address of the first element of the array. So that's the same as I've shown you before. Now, let's go on and print out all of the elements in the array, and let's use the bracket notation and let's use the pointer notation. So I'm going to scroll down, and Here we have the very same thing we did in the previous video with the array odd. So I'm just going to use the same thing here, and we'll print out the values of the array even. So when I put the code in for the internal part of the loop, then it really is the same thing that we had previously, except in this case I'm using the array even instead of the array odd. There was an extra curly brace down here that I just removed. Now, the for loop just goes from k up to, in this case, a number of elements, because we typed in how many elements we wanted in the array, so we don't know what that is as a constant. So we're going to use the elements as our stopping point, and k will be the index. So I'm going to print out the same table. We'll have even with the left square bracket, the value for k here, the closing right square bracket, and then the actual contents of the array here, and then we'll print out the address there. So it's the same as before, except this time we're using a dynamic array instead of a fixed array. And I move the system pause down here. Now let's compile the program and run it, and we'll generate this table. Now we have the output, so let's pop that up. And here you can see the table that we just generated with that loop. So we have the variable printed out on the left-hand column, the contents in the middle, and then the addresses over here on the right. So once again, you can see that this array is also storing all of the elements consecutive. They're all contiguous, so you can see the addresses, and you can prove that. So 76, 80, 84. Each element takes 4 bytes, so the addresses are increasing by 4 each time. And again, that's because every byte is addressable, so that's why we move by 4 each time. Let's go check the address of even index number 0 that we just did up here. So that's address 9340776, and yeah, so it's the same thing here. So you can see then that we can use the pointer notation. In this case, we're using the bracket notation to print out everything. Now let's go and print out the same table using the pointer notation. Here I'm using the same loop that I used in the previous video to print out odd using the pointer notation. And the code's going to look very similar. So the only difference again between this one and the previous one is that I'm using the variable even instead of the variable odd. So this is going to use the pointer notation in order to print out the contents of the array. Recall that if we want to use the pointer notation, then we have to use this. We take the beginning address of the array, we increment it by the value of k. That's the offset to go through all the elements. Then when we add those two together, we get the new address, and then we dereference it. So it's important to remember you have to do this inside the parentheses. So this now will print out the same information using the pointer notation. So let's run the program and take a look at that. Now we have the output, so let's look at that. And here you can see the pointer notation. So we show the pointer notation in the left-hand column, and now the contents are the even numbers, and we have the addresses for each one of the elements in the array. So this again shows you the pointer notation here, and here is the square bracket notation up there. I skipped ahead and I chose that I wanted 10 elements when we prompted for how big did I want the array. So I didn't show you that, but I went ahead and did that. So now we have the bracket notation and we have the pointer notation once again. Now, proceeding in the same way as we did with the odd array, let's see if we can look at a shorter way to print out this table using pointers. So that's what this one is showing here. We're going to print out using the alternate pointer notation. So we have the same for loop. We are going to use pointer 1. Pointer 1 is just a pointer to an integer. And we're going to initialize it to the address of even, the first element of the array. Then we are going to keep going until we get to even plus the number of elements that we typed in. So that gets us to the end of the array. And one more time, this is going to be an address. We take the beginning address, we offset it, and that gives us an address. We compare that with the beginning, with this address over here. So we're comparing addresses. And then we just increment the pointer using the plus plus notation. All right, so now let's put the code in order to make this loop work. So the line of code looks like that. And this one is the very same line that I used when we printed out the elements of the odd array. because I'm using pointer 1 again. So I'm setting pointer 1 to even, whereas in the previous case I used odd, and I used odd plus 10 over here because we only had 10 elements. With dynamic arrays, we don't know how many, so I'm going to use the variable elements instead of the number 10. So this then will print out the same information, but we don't have the variable, really. We don't really use even in here anywhere. So I'm going to print out the value of the pointer as we change it, and I'll print out the dereferenced thing that it points to. So there will be 2 columns in this table. So now let's go ahead and compile the program and look at this output. Now we can look at the output, and here's the table that we get. So using the alternate pointer notation, we just initialize pointer 1 with even, and then we can add the increment off of pointer 1 this time until we get to the end. So we're changing pointer 1, but we're not changing the address of the array even. We're not changing that one. All right, now if we compare this to our other tables, then let's look at the addresses. So the beginning address here, remember the 360, so 6360 is at the end, and we know the beginning address here is the same thing. So here is the an alternate method where you can use pointers to go through an array and you print out the values. So that's shown here. Now, let's move on and let's try using even as a counter. Now, you may recall from the previous video that when I tried to use odd as a counter or as a pointer, then I got an error message. It would not let me do it. Let's try it again, but let's use the address even this time, and let's see if that will work. So we have the same for loop that we were using for the odd array. Now, let's see if we can do the same thing with even, and let's see if it lets us do it or whether or not we get an error. We'll need the code to go in the middle of the loop, and here it is. So k is going to go from 0, k up to the number of elements in k++. I'll print out the address. Okay, so even is going to be the pointer to the beginning of the array, so it is an address. And I'll dereference it to print out what it points to, which will be the even numbers. Then, to get to the next element of the array, I'm going to do the incrementation operator here on even. Notice that there is no red underscore. That one looks like it'll work. And the way that we can tell for sure is we can compile the program and we can see if it compiles and runs. And I'll give you the punchline, it does actually work. So let's go ahead and run the program and I'll show you, and then we'll come back and I'll talk about that a little bit. Now the program's running so we can look at the output. This time I entered 12 when I got the question, how many elements do you want in the array? I typed in 12 just to have something different. So the elements of the array now are 2 all the way up through 24, so we have 12 of them. And notice that it works. The value of even changes every time. So the beginning of the array even is at 488. So if we look back up, then we can tell, yeah, okay, it's 488. Or if we want to go really all the way back, then the value for even really is a number that ends in 488. So we use that as the beginning part of our for loop. Then inside the for loop, we increment even. So we're changing it. Okay, so now we add 4, we get 92, 96, and so on. So that's still the same, and we dereference that address, we get all those values. So you can do that here, but you couldn't do it with odd. So what's going on? Why can you do it with one, but you can't with the other? The reason is that with a dynamic array, you are allowed to do that. So when you make a dynamic array, then you are entrusted to keep up with that. If you change the address of the first element, then it will let you do it. It's up to you to maintain that address. If you wanted to get back to it, well, okay, that's up to you. But the operating system is not going to prevent you from changing the address of the first element of a dynamic array. In the case of odd, it is not going to let you do that. So if you declare an array like this, then that's processed at compile time, and you cannot change that address odd. It will not let you. But if you make a dynamic array, now you made it, you break it, it belongs to you, then it's up to you to manage it. So that's an advantage, with I've lost where I did that there. So let's go back up and look at it. When we do the new here, when we make a dynamic array, then it's up to you as a programmer to maintain that pointer. So you have a great deal of flexibility there, but you also have the danger of doing things that maybe you didn't want to do. It doesn't protect you from doing that. Let's go down to the bottom again, and you might have noticed that I've got a question here. Okay, what is the value of even bracket 0 at this point? Okay, we changed even as we went through this loop. So even has progressed. The pointer even, we've added to it every time. So when we finish that loop, then what does even point to? All right, well, the way to find out is we can just put a cout statement there. All right, so let's try that out and let's see what we get. So we'll put some code in here. So here are some cout statements. After the loop where we modified even, we will print out the value for even bracket 0. So that's just really a redundant line there that I don't really need. So we'll print out even index 0 at this point, and we'll also print out the address where even exists in memory. What address is that? So let's compile the program and let's run it again. Now let's look at the output. Okay, now print out the index 0 of even. So index 0 contains that. Okay, well, those things are not any of these nice even numbers that we had up here. So clearly what I'm printing out is no longer 2 or 20 or 24, none of those things. The reason for that is that the address of even is this one. Okay, let's remember the 1136 here. The first part will be the same. So after we finished with the loop, then we have an address for even that is 1136. The last address that we had in the loop was 1132. So we've added 4 onto that after we exit the loop. Okay, so that's what happens. That's the next address. So we have now changed the value for even, and it no longer points to the first element of the array. So that's just that thing you can do if you do a dynamic array. It's up to you as a programmer to be aware of this and to be able to manage it. If we wanted to, we could reset even, and then we'd be back to where we were. So if we wanted to, we could save the address of even before we change it, and then we could reset it. So let's do that, and then that'll be the last thing we do in this program. If we want to reset even to the beginning address, then we have to save it before we change it. So this loop is the loop that changed even as we went through the loop every time. So here you see the change. So before we entered this loop, let's save the address even into pointer 1. Now we're finished with pointer 1 after that loop, so it's okay. We can use pointer 1 here. So I'm going to copy the address even and save it into pointer 1. Now this loop is going to change even as we just saw. So if I want to reset it, then I can do this. Let's paste in some code. So I'm going to print out to the screen, I'm resetting even to the first element. So I'll set even back to the pointer value pointer 1. So I saved it up here, and I'll set it back here. So now even is going to point to the first element of the array, and now this will be okay. So now let's run the program, and let's look at the output. So now we have the result. So before we reset it, we still had even sub 0 was equal to this garbage number here. But then after we reset it to the first element, then even index 0 is giving us 2. And the address of even 0 is this number here, 14686504. So we can verify that again if we look back up here. Let's just go back to the beginning. Even is 14686504. So that's the beginning address. If we save that address and keep it around and we don't lose it, then we can always reset even back to that beginning value. So now at the bottom of the program, you can see what we've done. The address was changed by the loop. We reset it back to the first element, and then it's good to go again. So then that shows you how you can manipulate the address of a dynamic array. So that'll be, again, it's great power, but with great power comes great responsibility. So you be careful how you use that. That illustrates then how pointers are related to arrays, and it shows you a number of operations that you can do with them. So that, I think, will sum up all I wanted to get across to you right now, and we will continue with some additional things with pointers in future videos. Pointers are really useful, and in these examples I'm showing you, it might not be apparent why you'd want to do this, because it looks like pointers are more cumbersome to use than just ordinary square brackets. But the thing is, the pointer gives you a lot of flexibility that you don't have with the square brackets, and this last example kind of illustrates that. Well, that's enough for now, so let's take a break and stop the video here.